At first glance, Earth seems solid, stable, and unshakable. But beneath our feet, the planet is alive with constant motion. The Earth's outer shell, the lithosphere, is not a single unbroken piece. Instead, it is broken into massive slabs of rock called tectonic plates. These plates slowly float on a softer, partially molten layer of the mantle called the asthenosphere. Though they move only a few centimeters per year, about the speed your fingernails grow, the forces they carry are enormous. When these plates collide, slide past each other, or pull apart, stress builds up along their boundaries. Eventually, that stress must be released, and when it is, we feel it as an earthquake. The three main types of boundaries. Convergent boundaries, plates collide, often creating subduction zones where one plate dives beneath another. These regions produce the strongest earthquakes and sometimes tsunamis. Divergent boundaries, plates move apart, creating new crust along mid-ocean ridges. Earthquakes here are usually weaker but frequent. Transform boundaries, plates grind past each other sideways. The most famous example is the San Andreas Fault in California. Hypocenter and epicenter, the point deep underground where an earthquake begins, is called the hypocenter. Directly above it on the Earth's surface lies the epicenter, which usually experiences the strongest shaking. Seismic waves, the invisible destroyers. When the stress releases, energy radiates outward as seismic waves, P waves, primary, compressional waves that travel the fastest and arrive first. S waves, secondary, slower side-to-side waves that are more destructive. Surface waves travel along the ground itself and cause the most visible destruction. Together, these waves can shake cities, topple buildings, and reshape landscapes. Measuring earthquakes. The Richter scale measures magnitude, the total energy released. It is logarithmic. A magnitude 6 quake releases 32x more energy than a magnitude 5. The Mercalli scale measures intensity based on human perception and damage. Earthquakes can be so small they're detected only by instruments, or so massive they can devastate entire regions. The experience of an earthquake rarely begins with a dramatic explosion. It usually starts with a subtle vibration as the P waves, the fastest seismic waves, arrive. People often describe them as a faint rumble or the feeling of a heavy truck passing by. Seconds later, the S waves strike. These waves move the ground side to side, shaking buildings, tossing furniture, and throwing people off balance. Finally come the surface waves, rolling, heaving motions that ripple across the land like waves on the ocean. These are the most destructive, capable of collapsing entire city blocks. Though most earthquakes last less than a minute, the sensation for those experiencing it can feel endless. The main causes of destruction, the shaking itself, is only part of the danger. Earthquakes trigger a chain reaction of deadly effects. Building collapse. Poorly constructed or old structures crumble first, burying those inside. Fires, ruptured gas lines, and broken electrical grids often ignite massive fires that rage for days. Tsunamis, undersea quakes, displace massive amounts of water, creating waves tens of meters high that can cross entire oceans. Landslides. In mountainous regions, entire hillsides can collapse, burying villages and roads. Infrastructure collapse. Bridges fall, roads split, water and power networks fail, cutting off rescue and aid. The greatest earthquakes in recorded history. Lisbon, 1755. On All Saints' Day, a massive quake estimated at magnitude 8.59.0 devastated Portugal's capital. Buildings collapsed, fires raged, and a tsunami followed. Between 60,000 and 90,000 people died. The catastrophe shocked Europe, fueling debates about science, religion, and natural disasters. San Francisco, 1906, a magnitude 7.9 quake ripped along the San Andreas Fault. The shaking lasted less than a minute, but fires swept through the city for days, killing about 3,000 and leaving 250,000 homeless. Chile, 1960. The strongest earthquake ever recorded, magnitude 9.5. The shaking lasted more than 10 minutes, and the resulting tsunami struck Hawaii, Japan, and the Philippines. Over 1,600 people were killed, and millions were displaced. Armenia, 1988, Spitak. A magnitude 6.8 quake leveled towns where buildings were not earthquake resistant. More than 25,000 people died in a matter of minutes, highlighting how poor construction can be deadlier than magnitude alone. Indonesia, 2004, Sumatra. A magnitude 9.19.3 undersea quake triggered one of the deadliest tsunamis in human history. Waves up to 30 meters struck 14 countries, killing more than 230,000 people. Japan, 2011, Tohoku. A magnitude 9.0 quake generated a massive tsunami that devastated Japan's coastline. Entire towns were washed away, and the Fukushima nuclear disaster followed. More than 20,000 lives were lost. How cities react under stress. Traditional towns with clay or brick houses often collapse almost instantly. Modern skyscrapers built with flexible designs can sway dramatically but remain standing. Bridges and highways may fail unless engineered with seismic safety in mind. Some places, like Mexico City, are especially vulnerable because they are built on ancient lake beds. The soft ground amplifies seismic waves, making even moderate earthquakes catastrophic. The psychological impact beyond physical destruction, earthquakes bring profound psychological trauma. The ground itself, the one thing we assume to be stable, suddenly betrays us. Survivors often report long-term anxiety, phantom shaking sensations, and fear of returning to their homes. Unlike storms, earthquakes strike without warning, adding a terrifying element of uncertainty. Why do the biggest quakes strike the same regions? Earthquakes are not random. They cluster in well-known zones where tectonic plates interact. The most infamous is the Ring of Fire, encircling the Pacific Ocean. Here, massive subduction zones and transform faults store centuries of stress before unleashing it in catastrophic events. That's why Japan, Chile, Indonesia, and California repeatedly face devastating quakes. Scientists know that in these regions, it's not a question of if the next big one will strike, but when. Can earthquakes be predicted? Despite decades of research, no one can say exactly when and where an earthquake will occur. But scientists use several tools to estimate probabilities. Microquakes, tiny tremors that sometimes signal stress buildup. Ground deformation GPS and satellites detect millimeter-level shifts in the Earth's crust. Gas emissions, unusual releases of radon or changes in groundwater chemistry can precede major events. Still, these are not precise predictions. Instead, scientists speak in probabilities. For example, there is a 70% chance of a magnitude 7 or higher quake along the San Andreas Fault within the next 30 years. Early warning systems seconds that save lives while long-term forecasts remain elusive. Early warning systems are real and effective. In Japan, a dense network of seismic sensors detects the first P waves. Alarms are instantly broadcast on TV, radio, and smartphones. High-speed trains automatically stop, and elevators open their doors before the strong shaking arrives. In Mexico, citywide sirens blare when a distant quake is detected, giving residents valuable seconds to run outside or take cover. Though the warning might last only 10-60 seconds, those precious moments often mean survival. Human preparedness and protection. We cannot stop earthquakes, but we can reduce their impact. Earthquake-resistant buildings, flexible foundations, and shock absorbers allow skyscrapers in Tokyo or Los Angeles to sway rather than collapse. Drills and education. In Japan, school children regularly practice what to do when the ground starts shaking. Personal emergency kits. In quake-prone regions, families keep bags with food, water, medicine, and flashlights. Urban planning. Governments restrict construction directly over active faults or unstable slopes to avoid catastrophe. Megaquakes. The planet's deadliest threat. The most terrifying events are megathrust earthquakes with magnitudes above 9.0. These occur along massive subduction zones, where one plate plunges beneath another. The 1960 Chile quake, M9.5, remains the strongest ever recorded. The 2004 Sumatra quake, M9.19.3, unleashed the tsunami that killed over 230,000 people. The 2011 Tohoku quake, M9.0, reshaped Japan's coastline and caused the Fukushima nuclear disaster. Scientists warn that another megaquake is looming in the Cascadia Subduction Zone off the Pacific Northwest of the U.S. If it ruptures fully, it could devastate Oregon, Washington, and parts of Canada with both massive shaking and a towering tsunami. Earthquakes beyond Earth, our planet, isn't the only place that quakes. Marsquakes, NASA's InSight lander, has detected hundreds of quakes on Mars. They're weaker than Earth's, but prove that Mars is still geologically active. Moonquakes. Recorded by Apollo astronauts, some lasted for over 10 minutes. Because the moon lacks water and atmosphere to absorb vibrations, shaking there continues far longer than on Earth. Icy moons. On Jupiter's moon, Europa, cracking ice shells may produce quakes in the frozen crust, hinting at dynamic ocean world beneath. These discoveries show that quakes are not just an earthly hazard. They are a universal phenomenon of dynamic worlds. The domino effect of earthquakes: one major earthquake rarely stands alone. Aftershocks, smaller quakes following the main event, can continue for days, months, or even years. In some cases, these aftershocks cause more damage than the original quake because already weakened structures finally collapse. In addition, major earthquakes can trigger chain reactions. Landslides can block rivers and create dangerous natural dams, which later burst and flood valleys. Tsunamis can travel across oceans, devastating countries far from the quake's epicenter. Earthquakes and human history. Throughout history, earthquakes have shaped civilizations. Entire ancient cities were abandoned because of repeated seismic destruction. In Greece and Rome, temples and theaters were rebuilt multiple times after tremors. In China, devastating quakes killed hundreds of thousands, leading emperors to see them as omens that their rule had lost the mandate of heaven. Even today, earthquakes leave long-lasting scars not just on landscapes, but on economies and cultures. A single megaquake can cost hundreds of billions of dollars and alter the course of a nation's development. Earthquakes as a window into the earth. For scientists, earthquakes are not just threats, but tools. Seismic waves act like X-rays of the earth, traveling through its layers and revealing its hidden structure. Thanks to them, we know that Earth has a solid inner core, a liquid outer core, and a layered mantle. Without earthquakes, much of this knowledge would remain a mystery. A reminder of our fragility. Ultimately, earthquakes remind us that we live on a restless world. We design cities, build monuments, and create technology, but in seconds, the ground beneath us can undo centuries of human effort. And yet these same forces are the heartbeat of our planet, keeping it alive and ever-changing. To understand earthquakes is to understand not just a natural disaster, but the very engine of Earth itself. Earthquakes are not merely disasters, they are reminders that our planet is alive. The same tectonic forces that topple cities also build mountains, open oceans, and recycle Earth's crust. Without them, Earth would be geologically dead, like the moon. For humanity, the challenge is clear. Earthquakes will never stop. But with science, preparation, and resilience, we can reduce their toll and adapt to life on a restless planet.